Oh yeah, last section of this chapter. So second derivatives. So you have done most of this in the previous sections already. So for these sections, it's a little bit of like increasing your knowledge, like okay, expand your knowledge. Okay, second derivative. So if the original function is y go fx, then you differentiate it. Differentiate is also known as d dx. Differentiate with respect to x. Then what you end up with is dy dx, or if its function is fx, then you differentiate it, you call it f prime of x, the differentiation or the derivative of x. So this is the first derivative. Okay, then if you differentiate a second time, again this is differentiating with respect to x again. So you get d square y dx square. If you want to be easy, you can think of this one as multiplied in, so you get d square y dx square, but it's not that real meaning. Okay, you know that in your university, so later on you know it is not multiplying by d dx. Okay, but then it's okay. So if you want to remember in that way, so yeah, so you do it. So d square y dx square, or the second derivative. Then after differentiate one more time, you call this f double prime of x. Okay, so this is second derivative. One thing you need to take note is that d square y dx square, this is totally different from dy dx the bracket square. Left hand side means the second derivative. Right hand side means dy dx times dy dx itself. Okay, so remember second derivative, the square on top is written in on top of d, then the square below is written on top of x. Okay, great. Turning point revisited. You know what's turning point? Turning point is point where it changes f prime. Okay, so y is equal to fx. You normally, how you find this? You set dy dx is equal to 0, then you find x. Okay, then that's turning point. That's turning point in SPM. Okay, the real definition might be a little bit more complex, so you just ignore it. How you find turning point in SPM is just to set it to be equal to 0, set dy dx equal to 0, find x. Okay, then you substitute x into d square y dx square. If d square y dx square second derivative is bigger than 0, then it is minimum. Then it's minimum point, bottom, like bottom. Okay, so if it's less than 0, then it's maximum point here. Okay, no problem. So this one is a revision of a previous section. Great. So let's do some example here. Like, okay, so your function here has two turning points, 1 and 2, and variable. Possible questions in SPM always. Okay, find h and k. Very easy. What we do, we write down our fx. Then like k. So if you want, you can try it yourself first. If not, then we do it now. Okay, so first f prime, differentiate this one. It gives you 6x squared minus 18x and plus 12. You set it to be equal to 0, right, in order to find turning point. So you set this one to be 0. So it means what? It means you can, you see, set it to be equal to 0. Hence, you can divide both sides by 6 because you see common factors, 6 here. Okay, divide by 6, x squared minus 3x plus 2 equals 0. Very simple, x minus 2, x minus 1. So x is equal to 2, x is equal to 1. So these are the turning points, okay, in SPM. Okay, x equal to 2, what do you do to find the coordinate? You substitute 2 into here, is it? No, you substitute this 2 into the original function because turning point is a point on the curve itself. So this one has to be substituted here. So x equal to 2, when x equal to 2, y is equal to 3. When x equal to 1, y is equal to 4. So you can compare, you see these two are the turning points. You compare these two with these two, then you can find h and k, right? 2 and 3, 2 and 3, oh here, okay, so h is 2. Then 1 and 4, 1 and k is 4. So h is 2, k is 4. As the same as my answer, okay, right? Second, you want to determine whether the turning points are maximum or minimum. So what you do here is to find the second derivative. Okay, differentiate second time, you call it f double prime because the function here is given by fx, not y. If it's y, and normally you write dy dx, d square y dx square, but this is fx, so you write f prime and f double prime. Okay, differentiate second time, it's even easier. But let me ask you this, differentiate, so you look for the things that is like expanded version to differentiate. Okay, so you don't differentiate the one that you group up nicely to be in bracket form, something like this one. You don't differentiate this because it takes more time, right? Okay, if you differentiate things like this one, then it gives you this one. And again, just now we were solving for this one equals 0. So don't simply differentiate this one. Okay, it's wrong. This thing equals 0 means this thing equals 0. But f double prime is not differentiation of this one because this is not f prime. This one equals 0. Hence you divide by 6. Okay, so you are differentiating this one. Okay, so differentiate, you get this one. Turning point 2 and 3. You substitute this 2 into here. So f double prime 2 is the notation. Okay, it's equal to 24 minus 18, 6. Bigger than 0. Bigger than 0 is like terbalik one, right? The other way around. So it should be minimum. Then the other turning point 1 and 4. You substitute this 1 into here, you get -6. Less than 0, so it's maximum. Okay? Okay, same as my given answers here. Alright, no problem. Let's move on. Okay, it takes you a little bit of patience to finish this question. So pause the video and try this yourself. Okay, you need to be writing it out, and it's kind of long, especially for the second question. Yeah, for the second question, second derivative. All right, so let's do it. So y is equal to this thing. So what I can do? You use quotient rule? No, I think no. You use this one, it's easier, right? You write in this way, then you differentiate it using chain rule. Bring this down, differentiate inside. Okay, so dy dx is the power, bring it down. This thing, power minus 1. Power -12 minus 1 is -3 over 2. -3 over 2. Then differentiate inside. This is the differentiation of this one. Okay, differentiate x minus 3, it gives you 1. Okay, then hence you get this thing over here, which is the answer for dy dx. Okay, d square y dx square, easy. Differentiate again. So this one, put it down. So multiply by this thing minus 1. Okay, then differentiate inside, again it's 1. Okay, so I write it down nicely. So it's this one. If you write in a nicer form, then this is power, this is root. The negative means what? You write below. So you get this one. Power is 5, root is 2. Power 5, root 2. 2, ignore, no need to write. Okay, square root, so you don't write the root there. Okay, so that's the answer. Great. Okay, good. So this is the answer. Move on to the next one. Okay, this one a little bit more difficult. So can you use the same thing as just now? What you did was just to put this to power negative something, -1 over 2. But for this case, cannot write. So what you can do is only quotient rule. You can do product rule as well if you want to move this on top and do the product. But yeah, since I'm doing this one, I might as well just do quotient. It's the same. So I take the bottom, differentiate the top, so I get 1. And minus the top, differentiate bottom. Differentiate bottom is a little bit more difficult. This is 1 minus 2x to the power half. So half, I bring it down. The whole thing power of -12. Then differentiate inside. Differentiate inside gives you what? -2. Yes, -2 is here. The whole thing divided by bottom square. Bottom square. Okay? So I can write down nicely. So this thing I write in terms of square root. This thing -12. So I write below square root. Okay? 2 and 2 cancel off. And then I can rewrite it nicely to be this one. And also rewrite it. So you need to be very good in writing all this and collapsing them. Okay? Collapsing them and combine them to be in one term. So it's easier. So you get this one. Okay? So this one, I treat this as the final answer. You can have something that's like that looks nicer, which you write at bottom, but it's okay. I'll just write it like this. Okay, and you see that how do I get this -2 over 2? How do I get that -2 over 2? this one is what? At the bottom, and this one is at the top of the bottom. So these two should be multiplied together. So this thing power 1, this thing power half, so they add up to be equal to 3 over 2. And it's bottom, so it's minus 3 over 2. Okay? Get this? Alright. Next, I shall differentiate this one using product rule. Okay, product rule. So I keep the first one, differentiate the second one, differentiate the second one using chain rule. Chain rule, so I bring the power down here, then the power decrease by 1. Decrease by 1 means minus 202 for this case, so minus 502. Then I have to remember to differentiate inside, which gives me negative 2. Then plus, I keep the second one, differentiate the first one, that's slightly simpler, so it's negative 1. And I shall just multiply them. Okay, it's a skill now that you need to know like which are the common things that you can bring it out. Okay, because this question says simplify. Okay, actually it means simplify. If not, it says find the second derivative, you can just stop here. Okay, normally you have to simplify to get a nice answer. Okay, so you have to see which one are the common factors. Common factor is 1 minus 2x, 1 minus 2x. But what power to take? You take this one. Okay, so you might not know why, but you take the smaller one. Okay, the smaller one. So this one is kind of smaller, so you bring it down. Okay, so you see what happened here first. Okay, I bring this out, so this one is covered. This has to be written here. Okay, this has to be written here. Okay, then after that, here, this is minus 1 is outside. Here, multiply by what? I'll get this one. Okay, negative 502, I multiply by what? I'll get negative 302. So that answer is 2 over 2. Okay, because negative 5 plus 2 is negative 3. So you get this one. Okay, so 2 over 2 is a nice answer, right? It's 1. Okay, that's why. So this one, if I tell you, it won't help you. Because I tell you now, you won't remember next time. So what you can do is to redo yourself. Try for taking out negative 5 over 2 and try for taking out negative 3 over 2 and see what's happening. Okay, then you get a feeling of that. Both also will give you the answer. Okay, one might be like terbalik, but then the answer is just of different form. Okay, both are alright. So you see this, after that you multiply this, write it nicely, expand it, then you got this one. Okay, now rearrange it, I get 2 minus x and that thing. Okay, so I can write in this way, which just repeated already, so this is not necessary. And then that one will be your final answer. You just bring that thing down, and power is here, root is here. Power is 5, root is 2 or square root. So square root 5, and that's your answer. Okay, great. So this one takes a little bit of patience, and you got to be very, very careful in the writing here. Okay, so just try to write it nicely so that when you have a problem, you can check your answers. If not, you have to redo again. Okay, so homework time. So find the second derivative of the following functions, so these two, and find the turning point of the curve and determine whether it's maximum or minimum. Okay, so just pause the video, look at this one, pause the video, look at this, then we just reveal the answer. Okay, nice. Okay, so let's see this. So y prime or dy dx is this thing. I use y prime. Okay, so if you are not comfortable, you use dy. Dx is totally fine. This is d squared y and dx squared. Okay, dx squared. Okay, so these are the answers. Let me see. Is there anything that I need to explain to you? Left hand side, I'll leave it for you. Okay, I'll try to do this one for you. Okay, explain this one to you. So you want to find what? Turning point. Turning point is a point where the f prime x change. So f prime is this one. You set it to be equal to 0, then find the x. The x is your turning point. So you want to find the turning point as a coordinate. So you substitute this x equal 3 back into fx. So f of 3 is this thing, then it's equal to 1. So the coordinate is 3, 1. So turning point is 3, 1. Okay, now you want to know this turning point, whether it's a maximum point or minimum point. So 3, 1, you substitute the 3 into f double prime x. F prime x is 2x minus 6. So f double prime x is 2. You substitute 3 into f double prime x, it's still giving you 2. You substitute 5, it's still giving you 2. So I don't have to substitute anymore. So because it's always bigger than 0. So that thing is minimum. Bigger than 0 is minimum. Alright, local minimum. But your context in SPM is only minimum. You just say minimum. It's a minimum point, it's sufficient. Okay? Alright, we are done for the chapter. Yes. Okay, I'll see you in the next chapter and